Sarah, what's up?
Good evening, sir. Good evening.
Hey, good evening, guys. Okay, let me 1 minute. Let me check. Hello, Rennie. 1 minute. I can change my methodology to pull the GRP. I have auto sum. We have done with the authenticate. Sorry, auto summary. B6 we have done. Manual summary we have done. Name the model. We'll see the later packets. Passive interface. We'll see path manipulation. Right. So let me show you the first thing that step interviews is that EIGRP stuff. So we have done with this part. So yesterday I have shown you the manual submission concept, right? Let me write a few things over there. So null zero route, right, is used to prevent data plane view, right? And 85 that we have in the EIGRP is used to prevent what control plane. This mistake. All done, right? So we have covered this point. So I know it's a bulky right now. Let me remove all those things. It's too bulky. Okay, let me remove this guy, remove this guy, remove this guy, and remove. Now it's simpler, right? Simple one. So if you go a little bit above over here, now, so you can see that we have a router 1 and router 2, router 3, router 4 right now. So what I can do that right now, I'm just gonna configure the IP addresses on the all the router 1, router 2, and router 3, router 4. And router behind the router 4, you can see that I have a few networks like a class pool. I have 4.0.0/8, 44.0/8, and the classless network I have 172.16.10/24, right? So let me do the basic configuration. What I can do, I'll just use my notepad file. I think so pre-configuration will be there. EIGRP metric calculation. On router number 1, let's start my keyboard. On router 1, what we can do that, we just need to configure interface 0/0. IP address will be 12.1. Okay, the subnet that I'm using right now, you can see that, guys. The subnet I have between the router 1 and router 2, it's a 12.0. So 192.168 x.x. X means 12. R1 to R3 is 30. R3 to R4 is 34. And R2 to R4 is 24. So we have a 255.255.0/24. No shut interface 0/1 IP address will be 13.1/24. And I'm gonna also configure the EIGRP. So better to configure the EIGRP one. EIGRP router ID, manually configure it, and also the network 0.0.0. Based on the single command line, I can input as both the network, right? So same way in router number 2 we have. On the router 2, we'll just copy this configuration, right? Only the few things we need to change. On this guy, we need to the 12.2. Right, and this guy should be 0/1 should be 24.2. So on the router number 2, you have a 2 IP address 12.2 and 24.2, and the EIGRP router ID also should be changed, and the remaining network string will be the same, right? R3 we have now. R3 we have if you see, we have R3 on the 13.3, we have 0/0. Then we have a 34.3. And then router ID will be 3.3.3.3. And the last, we have router 4. So on the router 4, we need to add a few more commands. So apart from the IP address, 24.2, and this should be the 34.4. And this should be the 4.4.4.4.4. And here we go with the network 4.0.0.0.0, network 44.0.0.0, right? And I have another network 172.16.1.0, and I can define the wildcard bits. Why I'm defining the wildcard bits for this guy? Because it's a classless network, right? It's not mandatory to define the wildcard mask. It's optional, but the best practice, you need to give this one. If you're not going to give in the examinations, the examination will give you the 0. Still, you can send the traffic, but examination will give you the 0 marks for that one. So all done, that's my router number 1. So let me configure it. So let's with some time, man. All good. All routers we have now. So let me remove the router 1. I have duplicate console of the router 1. So on the router 1, what we can do that? If you see the verification right now, so IP interface brief, I have already a IP configuration that I did it over there. I just need to configure the EIGRP on router 1. That's all. So let me check it. Do we have a protocol or enable or not? Oh, it's not there. I have a RIP enable. Let me remove it. RIP on router 2 as well. Do show IP interface brief. I already have IP. Do show IP protocol summary. This is a very beautiful command that will give you what protocol you have enabled. So no router EIGRP, no router RIP. All good. On a router 4 as well. So IP interface brief. All good. So IP protocol summary. It's there. Let me enable it. No router EIGRP 1. And on R3 as well, because I want to do the IP from EIGRP from the scratch. That's why I'm removing the EIGRP from every router. So no router EIGRP number 1. Okay, so let's start with the EIGRP configuration router 1. All good. Same way we have a router number 2. All done. Same way we have router 3 now. All done. Then we have router 4. So R4 must have a three extra IP if you see that. So I just have one loopback, right? I need to create the another loopback. So better to do one thing. Let me create it over here. Interface loopback number 1, 404. And interface loopback number 2, that's a 44.44. All done. And I have another loopback, interface loopback 3, that's a 172.16.1.1. It's a classless route, okay? So I'll just copy and paste it on router 4. Bingo. So now if you want to verify, one quick question to all of you guys. Can anyone tell me how many neighborship that R1 is going to maintain right now? How many neighborship R1 is going to maintain?
2.
2, right? So one is going to maintain the neighborship R2 and R3, right? So if you see, show IP EIGRP neighbor, our 2 neighborship. Perfect. On R1, I have a 2 neighborship R2 and R3. Now it means that, right? Even router 2 is also going to maintain the 2 neighborship, one with the router 1 and router 4 as well. If you go on the router 2 right now, router 2 also going to maintain the 2 neighborship. One is going to maintain with the router 1 and one is going to maintain with the router 4. Even if you check on the router 3 right now, do show IP EIGRP neighbor. Router 3 also going to maintain the 2 neighborship. One is going to maintain with the 34.4, that's router 4, and one is going to maintain with the 30.1, that's a router number 1. If you check on the router 4 right now, do show IP EIGRP neighbor. Router 4 also going to maintain the 2 neighborship. One is going to maintain with the 24.2, which is the router 2. Another is going to maintain with the 34.3, which is the router 3. And how many interface has been enabling the on our R4 router? So there will be a 5 interface. If you see show IP EIGRP interface, our 5 interface is enabling the EIGRP, right? One, this is 0/0/1. Loop back 1, loop back 2, and loop back 3. 1, 2, 3, 4, 5 interface has been enabled. Now let's go on the router number 1. If you check the routing table show IP route EIGRP, what you will figure out, you will see this 4.0 network, all these 3 network, right? I'll just consider the one right now. So you will see all these 3 networks are received by the both the path. Received by the both the path. So I put the router EIGRP, you can see that, right? So I'm getting the 4.0 from the 13.3 and 12.2. I'm getting the 16.0/16 via the 13.3 and 12.2 as well. And I'm getting the 44.0 via the 13.3 and 12.2 as well. One thing, if you notice that what I'm receiving the route over there, I just configure the /24 subnet on the router 4, but I'm receiving a /16 only. Can anyone tell me what's the reason behind it? Anyone tell me why?
Because of auto summary?
Because of the auto summary, right? Because auto summary is by default enabled. If you see the SOIP protocols, and my auto summary is enabled. So what you have to do that. So version, let me check which version I'm using right now. It's 12.4. That's an older one. So by default in the older one, auto summary is enabled. So better to do one thing. The good practice is what? I'll say the no auto summary. On R3 as well, no auto summary. On R1 as well, no auto summary. On the router 2 as well, no auto summary. So now every router, you just need to go and disable the auto summary behavior. No auto summary. Again, it's totally depend on the requirement. If your auto summary is enabled, then need to disable it. If it is already disabled, there is no need to put the extra commands. So now you will receive the exact route on the router 1. So if you see now, do show IP root EIGRP, have a beautiful output. So previously I was getting this amount of route, if you see, right? Now I'm getting the /24. But the thing is that you can see that the traffic. So if I'm going to send any packet, for example, there's a user sitting behind the router number 1 and say that, hey, let's send the packet to the 4.4.4.4 network. Then what happened in that case, when the router will receive this packet, what router will do that? The packet will have a source will be x.x.x.x.x. Destination will be 4.4.4.4. Whenever the router receive the packet, it always do the destination lookup. And based on that destination, it will forward the packet to the router. And that's why it's called as a destination-based routing. So when the router 1 will receive the packet, it will say, hey, according to my routing table, I need to forward the packet to the 13.3 and 12.2. So it will do the load balancing. It will perform the load balancing. And this load balancing is called as the equal cost load balancing. Why I say the equal cost load balancing? Because the cost, or we can call as a metric, right? The cost and metric both are same. Can you see that? From if I go via this way, the metric is 435.200. And if I go via this way, the metric is same right now. So by default, right? By default in EIGRP protocol, in OSP protocol, and even in the RIP protocol, by default, EIGRP, not EIGRP, I'll just mention all IGP protocol does perform the equal cost load balancing. There's a two types of equal cost load balancing. One is called a per destination, right? Another is called a per packet load balancing. Per destination is a by default right now. Sometimes it's called as a per flow as well. So it's a by default right now. Nowadays it's a by default. Per packet is not a by default. In our initial days when the networking was growing, on that time the load balancing was a per packet, right? Now it's a per flow. Per flow means what? Per packet means what? Per packet in the sense means, for example, if the PC is sending the 100 packets, right? The 50 packets will go via this interface and 50 packets will go via this interface. That's a meaning of per packet. Per destination means what? Or we can say the per flow. Per destination and per flow means what? Depend on the flow. So flow is what? Flow is a combination of source IP, destination IP, right? And then we have our source port number, destination port number, and then we have our protocol, layer 4 protocol. So when you have all this, even you have one more thing that's called as a DSCP field. That's a higher level. In IP header, we have a one field is called the DSC field. It's used in the quality of service. So when you have a same source IP, same destination IP, same port source port number, same destination port number, same airport protocol, same DSC field, this is called as a one flow. This is called a one flow. Understand in the easy language. The meaning of per flow is this is when you have a same source IP, same destination IP. So when this PC is gonna send the packet to this particular subnet, then what happened? This particular PC, take example. Then you have a same source IP, same destination IP, same port number, same destination port number, same protocol, and same DSP. That's called as a one flow. When another PC will send a packet to this guy, then what happened? It will have a different flow over there. So now we have two different flow. So when it comes to the per destination, in the per destination, what happened? For example, things will change like this way. So for example, if this PC will send a traffic, right? So it will take via this flow. So my all packet will go via this flow. And when this PC will send the traffic, it will go via this flow maybe. So it's totally depend on the hashing algorithm. You don't need to do anything. It's hashing algorithm is found by the router itself. Again, I know it's a little bit detailed. Ignore it. You don't need to know this part until unless you are not an architect level. So just remember one thing, you have two types of load balancing algorithm. One is called a per destination, one is called a per packet. In a per packet, what happened? The packet will be divided. 50% packet will go this way, 50% packet will go this way. In a per destination, what happened? For each particular users, right, traffic will go by the different way. So for PC1, it will choose this way, or PC2, it will choose this way. So default is right now, it's a per destination. So in load balancing, basically in an equal cost load balancing is by default performed by all the IGP protocols. Why I mentioned all the IGP protocols? BGP by default does not perform the equal cost load balancing. Now the question is that why the EIGRP is performing the equal cost load balancing? Because of the maximum path. So if you see SO IP protocol, what you can see that maximum path is 4. The maximum path 4 is representing it. A router can receive the path. For example, there's a 4.0.0 behind the ISP, right? So router can receive the path from the different 4 ways. So if they have a 4 links, they can receive the path from the 4 ways. But if I'm gonna make this guy a 1 over there, then what happened? It can only receive the path from the 1 base. So by default, right now it's a 4, and that's why what happened? I can get the route from the 2 different ways. That's fine. Up to 4 is there, right? So I can get the route from the 2 different ways. But if I'm gonna make this guy as a 1, what happened? It means that you are disabling the equal cost load balancing. If I'm gonna make this guy as a router EIGRP, by default, max path is 4 in all routing protocol. iOS, not the iOS XR, not even the iOS XC, not even the Nexus. It's only on the iOS. You can change up to 16 in older iOS version and 32 in newer iOS version. Again, guys, we are talking about the iOS perspective. XR has a different values. XC has a different one. Nexus is a different one. Okay. So कल ऐसा नहीं होगा कि you guys are going in the high level things like a service provider, you're doing the training and you say, oh no, you told me that it's only gonna go up to the 32, but I see it's a 64 somewhere and 648 somewhere. So it's very depend on the platform, depend on the vendors, by vendors, it's very okay. So by default, it's 4 in the iOS. If you make this guy, if you make 1, it means that you are disabling equal cost load balancing. Sometimes this terminology is called as ECMP, equal cost multipath. Sometimes this is called as ECMP, equal cost multipath. So if I say the maximum path 1, now if you see that do so IP protocol, what you can figure out, it's 1 now. So what happened? The router 1 is going to pick the 1 path only. Previously, I had a 2, 1. Now it's 1 only. The reason is that I have only one maximum path. I can only receive the path from the one way, either this way or this way. Again, if I'm going to make this guy a take example, if you see router EIGRP, so it doesn't mean that R3 is not sending the route. So R2 is also sending the route, R3 is also sending the route. But R1 is only accepting the route from R1 is only accepting the route from the router number 2, is not accepting the route from the router number 3. The reason is that I have only one maximum path right now. So if you see the do show IP EIGRP topology table, I have both the information. Can you see that? In my topology table, both the information there, but in the routing table, I can only put the one route. Okay, it doesn't mean that we are not receiving the route from this way. I'm receiving the route from this way, but I'm not going to make this guy the best right now. Because of the maximum path is only one configure. But if I'm going to configure this guy what? As a router EIGRP maximum path, you can see up to we can configure 16 in the older iOS version. That's 12.2 we are using right now. If you see, do show version include iOS, it's 12.4. It's an older one. So you can configure up to 16 only. So I can just make it this guy's up. Even if I'm going to make the no maximum path right now, right? It comes in the no maximum path 1. It comes in the default behavior. That's a 4.1. And now I can get the route from the both the way. So IP root EIGRP, you can see. So ECMP, right? ECMP equal cost multipath, or we ECMP equal cost multipath, right? Load balancing is by default enabled. Enable if you have a same cost, or we can say the same metric to reach the destination. Then it will perform the equal cost load balancing. If you see right now, we have the same metric from both the side. That's why router is doing the load balancing. Now, take example. So I have a packet. I can go to send the traffic from this way as well as I can send the traffic this way as well as. But do you know what happened? This is the default behavior. Okay, of course. So take example. Okay, first understand this concept, how this metric comes in the picture. So there is a formula for this one. So if you remember that I told you that. So we have a K1, right? K2 we have, K3 we have, K4 we have, right? And K5 we have. The K1 is called as a bandwidth. K2 is called as a load. K3 is called as a delay. K4 is called as a reliability. K5 is called as a MTU. What is the default one we are using? We are using the bandwidth and delay only. The reason is that because these are the static in the nature. Load reliability in the dynamic in the nature. When the traffic will be high, guys, please pay attention to my words. When the traffic will be high, then what happens? Load will be increased and reliability will decrease. So that's why these are the dynamic in the nature. And that's why we are not using this one for the metric calculation. So what is the how the EIGRP calculate the metric? There is a formula for this one. What you can do that? The formula is 10 to the power 7 by least bandwidth. Least bandwidth is smallest bandwidth plus total delay we have. And then divided by 10 over there into 256. So if you see the metric of bandwidth of each interface, I have mentioned already there. So the bandwidth of each interface is what? 10,000 kilobits. If you see that, go on the router. So interface 0/0. Right? This guy also 10,000 bits. And this guy also, this is the interface also 10,000 bits. Same with this interface also 10,000 bits. And this interface also 10,000 bits right now. Right? Same with this interface also. Same interface also 10,000 bits. And this interface also 10,000 bits over there. Same with this interface also 10,000 bits. And this interface also 10,000 bits over there. And delay is a 1000 microsecond. So delay, if you see, no, 1 minute guys. Somewhere change something. Oh, that's fine. I thought something had changed in the configuration. So if you see the delay is a 1000 microsecond. So the delay is also configured is what? This is the bandwidth part. And if I talk about the delay also has a 1000 microsecond. I'm busy right now. Very. So the delay is also like what? 1000 microsecond. And the delay is also 1000 microsecond. So this is the bandwidth and this is the delay. This is the bandwidth, this is the delay, this is the bandwidth. Again, this is the bandwidth and this is the delay. Same way, if you see that, this is the 1000 microsecond and it's also 1000 microsecond. This is the 1000 microsecond over there. This is the delay, again, this is the bandwidth. This is the bandwidth, and this is the delay over there, 1000 microsecond. These are the default delay and bandwidth for the each interface. Loopback has a different one. If you go on the router 4 right now, so interface loopback number 1, it has a 5000 microsecond right now. So this guy has a loopback, has a bandwidth is what? What bandwidth will be 1, 2, 3, 4. How much? 3, 2, 6 over there. And if you see the delay for this guy, it's a 5000 microsecond. So this value will be changed according to the link bandwidth, right? Interface one. So gig has a different one, 10 gig has a different one, 100 meg has a different one, 10 meg has a different one, serial link has a different one. So this will be vary. You don't need to remember these things. Now, how this matrix calculation is happening? How does EIGRP find these values? 4352.0. So he figured out. So now you tell me which one is the, take example from the router 1 to the router for this network 4.0.0. What is the least bandwidth we have? If you see the least bandwidth, all they are using the same value, right? If you see that 10,000, 10,000, 10,000, 10,000 only. Even if you go this direction, 10,000, 10,000, 10,000 only, 10,000. This has a plus 8 lakhs. So minimum is what? 10,000, right? So what you can put over there? I'll put the 10 to the 7, 2, 3, 4, 5, 6, 7. Least bandwidth is what? 10,000, right? Plus total delay is what? The delay, always you are going to configure in the second. Remember this point. Always you are going to configure the delay in the second. What Cisco CLI is doing, they will convert into the microsecond. You're always going to configure in the second. It will convert into the microsecond. So the total delay is what? If you see the delay, 1000 microsecond, 1000 microsecond, right? 1000 for this subnet, we have 1000. For this subnet, we have a 1000, right? 1000 plus 1000 plus 5000. Total, we have a 7000 delay right now. Divided by 10 into 256. So if you're going to divide all this value, right? If you're going to divide all this value, then how much you will get? You will get the, this will be the only 4, right? Not the 5. 1, 2, 3, 4. And same way, I'm going to divide this guy to this guy. So you will get the 1000 plus 700, which will become the 1700 into 256. So if you're going to calculate this guy, if you're going to open the calculator, 700 into 256, you will get the 435200. Same values. Now, maybe you have a question. Hey, no, right now, this is the topology on the GNS3. You can get to know that. Okay, this is the interface. I can see that. But how in the production network, if I want to calculate this thing? So simple command, what you can do that. If you put the command show IP EIGRP topology 4.0.0/8, it will give you the all information. The total delay, 7,000 microsecond, that I already put it over there, and minimum bandwidth, the bottom one. So from this one also you can figure out. Now, this is the how you can, this is the formula. Okay, that's universal formula to find the EIGRP metric. That's how does the even the EIGRP calculate the metric based on this formula. Now it means that understand the concept. If you see one thing over here, what the measure part, bandwidth and delay, bandwidth and delay. Okay, so if we are manipulating bandwidth or delay, the path will be changed. Again, I'm repeating, if we are manipulating bandwidth or delay, the path will be changed. So bandwidth and delay plays the major important role to perform the route selection, to perform the best path. So right now, if you see, right now, if you see, router 4 has a, right, router 1 has a 4.0.0 information from the router 2 and router 3 as well, right? So it means that it will do the load balancing. What I want right now, try to understand. What I want right now, I want to make this interface as a best path, and this should be the second best path. The reason is that because I want all the traffic will go by the router number 2 to this network. If the router 2 goes down, then it will choose the path router 3. I want to make a path manipulation right now. I want to change the path for this guy. How do we do that? So the default behavior, if you see that delay is what right now? The delay is 1000 microsecond, right? This guy also has a 1000 microsecond. What I told you that delay always you're going to configure, right? Delay always you configure in second. Cisco CLI convert into microsecond. So if I'm going to configure the 10, they will convert into the 100. If I'm going to configure the 100, they will convert into the 1000. If I'm going to configure the 1, it will convert into 10 over there. Lower delay, right? Always prefer. So if I'm going to make a path manipulation, then what I can do that? So this is the 1000 microsecond. This is also 1000 microsecond. I'll make this guy the lower one. 100 microsecond. So if I'm going to make a 100 microsecond, 100 means what? If I'm going to configure the 10, then it will convert in the 100. So I'll just go on the router number 1, interface 0/0. I'll see the delay is what? 10. So if I'm going to configure the 10, it will convert into 100 over there. So now so interface 0/0 include delay. I just configure the 10 right now. What he did that, it convert into the 100 microsecond. Even if you just show interface 0/1 include delay, it's microsecond 1000 over there. It means that lower, this one is a lower one, and lower one is always preferred. Lower delay is always preferred. So what happened? Now this path will be not there in the routing table. R3 will be not there in the routing table. So now the path will change. So this is the best path now. So if you go to router 1 and say that so IP route EIGRP. So all the route 4.0, 44.0, and 70.0, all these guys coming by the 12.2. So this is my, I can call as a simple language. This is my successor route. And this is my feasible successor. So if you see on the topology table alpha, so IP EIGRP topology, right? I have a one successor for this particular network, which is this one, because it has a lower matrix. Can you see that 412160? Previously it was a 435200. So when I change the delay, it impacts the metric as well. So it has a lower metric will become the successor node. How would you know that this is the successor? Can you see the same FD over there? 412160. Same FD is present over there. So this is my successor one. And the bottom one, you can see that's a higher metric. It's a 4 lakhs something, and it has a 4 lakh 35. So 4 lakh 12 is a lower, 4 lakh 35 is a higher one. So it will become the feasible successor. Of course, right? If you see right now, so IP route EIGRP, this is my primary path right now. So if I'm going to lose this network, if I'm going to lose this interface, 0/0, if I'm going to shut down this particular interface, then what happened? Secondary comes in the picture. Do so IP route EIGRP in just a matter of minute. So just a matter of second, secondary comes in the picture. And so if I'm going to up this guy, then what happened? Primary comes in the picture. Just a matter of second. So always remember, whenever the path manipulation comes in the picture, lower delay is always preferred. So now if I'm going to remove the delay from this interface, I said the no delay. If I'm going to say the no delay, it comes in the default behavior. It comes in the default behavior. So if you see, so IP interface 0/1 delay and 0/0 delay, same one. So for the path manipulation, on auto one, lower delay is always preferred. So on the auto one interface 0/0 as the delay 10. So our 0/1 is a 100 configure and just the 10. Same way, what happened if you don't want to change the delay, you can go with the bandwidth as well, because bandwidth also part of the matrix algorithm. So in the bandwidth, what you can do that, the bandwidth is always higher preferred. Right? Or you're going to configure the bandwidth in the bits per second. So what again? So if I'm going to configure the bandwidth 10, it will equal to the 10 over there. So there's no issue in the bandwidth, only issue in the delay. So if you go on the router one, so bandwidth of the both interfaces same right now, right? So again, I want to make this. So right now, my routing cable, if you see, it's doing the equal cost load balancing. It's doing the ECMP right now. But I want to make this guy the best. So the question, how the question will become in the interview and the examinations. Hey, they will ask you, hey, you're gonna make this guy the best route. They will ask you, hey, you're gonna make this guy the best route, but you're not allowed to change the delay. So if you're not allowed to change the delay, then you have option is what? Bandwidth. So if you just go on the interface 0/0, also the bandwidth is higher, right? I'll make this guy a 10,000 default. I'll make this guy 1 lakh. So interface 0/0 include delay and 0/1. So if you see, it is a 1 lakh right now, and it's just a 10,000. So IP route EIGRP. Wow. Met. Shut down, no shut down. So interface 0/0 include delay. No, my bad. I increased that one. We need to decrease that one because list bandwidth is big, right? So let me remove the no bandwidth. And what I can do that. So list is preferred. So I'm gonna make this guys a list one. No, but still bandwidth is higher. I'm gonna increase this guy. 0/1, so replace 0/0, include delay. Come on. And 0/1 now. So this interface time, so I can be ejected. Yeah, it's coming to each other. So higher bandwidth is not. So the path that you don't pick, just make that as a lower one. The path that you don't pick, just make that as a lower one. See, the bandwidth you can use and change the, if you want to manipulate the path based on bandwidth, then change, lower the bandwidth. Which you don't want. So interface 0/1 as without data 1. Then now understand the concept, guys. If you see one thing, the first problem, focus on the problem right now. It means that for all the router, if you see for all the router, what happened? Router 2 is become the best. It means that we are not gonna utilize this particular resources. It seems like a CST protocol, common spanning tree protocol. We are not gonna utilize this particular segment over there. Because my best is what router number 2. So for all the network, it doesn't matter 4.0/8, 44.0/8, and 172.16 or 1.0/24. For all this guy, I'm gonna send the traffic from the 12.2. So I cannot utilize the router 3. This is the first problem. Second problem is what? Second problem is delay and bandwidth, right? Delay and bandwidth is directly impacting to your quality of service as well. Quality of service is a very smart, advanced topic of the CCI. And so majorly the quality of service is dealing with the 4 things. One is dealing with the bandwidth. Second is dealing with the delay. Third is dealing with the jitter. And fourth is dealing with the packet loss. Right? So the quality of service is dealing with all these 4 components. So if you're gonna manipulate the delay and bandwidth of this particular interface, try to understand what you think. Is this particular interface is only gonna carry the EIGRP route or BGP? They are also running with the OSPF and ISS protocol. Okay, forget the OSPF ISS. Apart from this thing, from this particular interface, the VPN also will be configured, the GRE also will be configured, the NTP protocol also will be configured. So if I'm directly changing the bandwidth of the particular interface, it means that I'm creating the problem for everybody, not for the EIGRP.
Okay.
You understood my point?
Yes, sir.
So see, I wanted to show you this thing, but it is never ever recommendation to do that in the production network. People are doing this thing. And then after that, they come with a problem. One thing I changed the delay, and then what happened? It's impacting the other services. So you may have this. So who is working in the production network, you may face this problem, right? So if you're changing something, it might impact into the other services as well. Because of that reason, few things that's never ever recommendation to change it, but people are doing this thing because lack of knowledge, right? Never ever do bandwidth and delay to perform the path. Okay, for the learning perspective, you can do that. Interview, if somebody will ask you, give the answer delay and bandwidth. If they are not satisfied, then you can understand, okay, he has a knowledge, then you can shoot the another answer that I'm going to give you right now. But if they are satisfied with the delay and bandwidth, just assume that. Then you can please see. I'll tell you one thing. Now, so the next, to avoid this problem, right? So EIGRP has another way to manipulate the path that's called as a offset list. Offset list is what? It's a one guy, understand in this way. This is the one guy, one person. What this person is gonna do that? It's gonna add the dummy, right? Dummy value, or we can say the dummy value is like an integer number to the matrix. So for example, what is the actual matrix that I'm getting? Let me change the bandwidth. Interface 0/1, no bandwidth. So everything is equal now. So interface 0/0. And 0/1. Everything is equal. So IP routing EIGRP, it will perform the ECMP now. Right? It will perform the ECMP now. Now, what value I'm getting from this? 43,000, 4 lakh or 35,200, right? So from router number 2, I'm getting the 435200, and from the router 3 as well, I'm getting the same values. So it means that it will do the load balancing. But what I want to make this guy the best. I want to make this guy the best. Simply what I can do that. I'm going to call this guy. That guy name is offset. What he will do that? He will add the dummy number, dummy value number to the what matrix. So I will say that, hey, listen, add the dummy number on this particular side, 1000. Or forget the one, I'm just going to add one. That's all. So it will become now what? Okay. Which one is the lower one? So always the router 2 will become the best. So I'm adding the dummy number. This dummy number I have added. Can you see that? This dummy number I have added on this particular matrix. That's the meaning of offset list. Did I manipulate the delay? No. Did I manipulate the bandwidth? No. Specifically only for the EIGRP, I'm changing this thing. So if I'm changing specifically for the EIGRP routes, I need to go under the EIGRP configuration. If you notice one thing, whatever the things that I have manipulated, I manipulate under the interface label. It means that under the hardware level, if you are dealing with the hardware level, you're impacting to the all person. Deal with the EIGRP level. So what I can do that, I'll go on the router 1 as a router EIGRP. Good. That's the offset list. And what? Also the 0 number over there. 0 means what? For all the input. Understand that this concept first. Then I'll go in the deeper as well. Don't worry about that. As the 0 means what? All the network. As the 0 over there. And then what? Inbound. Because we are getting the route. This route, because you are sitting on the router number 1, right? So if you are sitting on the router number 1, so you are receiving the route. You are receiving the route. This will become the inbound. So I'm saying the inbound. What? I'm going to add the offset now. How much? I just add the 1 over there. On which interface you're going to add? If I'm not going to put the interface, if you see, if I'm just going to put the command like this way right now, if I'm going to put the hit enter over there, then what happened? It will applicable for the both the interface. It will applicable for the both the interface. If you see, I have a CR carry return. I can hit the enter over there right now. But I'm going to mention over there, hey, no, wait. I'm going to apply this offset value 1 on this particular interface, 0/1. That's all. So now if you see the show IP route EIGRP, hold on. Bingo. Did I manipulate the bandwidth? If you see show interface 0/0. /1. Everything is perfect same. But I still achieve my output. So now the tricky question comes to you. Whenever somebody will ask you, hey, you have to change the path. You have to make the router 2 as the best, router 3 is a non-best. Router 2 should be the successor, router 3 will be feasible one. You are not allowed to change the delay bandwidth, then offset comes in the picture. Always remember one thing, offset list, right? offset list always gonna increment the value. It cannot decrement it. Offset list is gonna only increment the value. It cannot decrement it. Delay and bandwidth is directly impacting to all services because you are changing on hardware level. So better. So this is not scalable and not recommendation. So what you can do that, you can go with the offset list. So new guy comes in the picture, that's called the offset list. Offset list only for distance vector routing protocol. So the problem that this guy only work with the distance vector routing protocol. So you don't have these things in the link state routing protocol. That's one of the problems we have. But yeah, we distance link state routing protocol like OSPF, ISS, we have a different things. BGP, of course, that's a BABA, right? So EIGRP has only the offset list. RIP has an offset list. With the help of offset list, we can only increase the metric. So you can see that show IP routing EIGRP, I have a 2 because I changed the add the offset list 1 on this particular interface. So I just make this guys a 435201 and this guys a 435200. So if you check the show IP route, show IP EIGRP topology, you can figure out. See that?
Okay.
Perfect.
Yes, that's fine.
Question to you guys. Do you see any problem over there? So all my traffic will go by this way. All my traffic will go by this way. So do you see any problem? Yes, I see. What? I see. Okay, one more thing. So on the router number 1, I did the what configuration? Let me do this. Or let me show you that. On router 1, I did the router EIGRP. When I see the come on. Hold on, I'm coming to the point, guys. On router 1, I did the offset list in one direction. You can do the same configuration on the router 4 as well, man, if you want. For example, you don't have a control of the router 1, and if you want to achieve the same output, you can do on the router 4 as well. Instead of the in, you can see the out on which interface 0/1, because I want to send the higher metric add +1. So you can do the out direction on the router 4 as well. So depend on the regard. So for example, if the condition comes like that, okay, you are not allowed to change anything on the router number 1, not even the router 2, router 3, router 4. How you will change that? On the router 4, you can do that in the out one direction. What problem I feel that right now? The problem is what? So if the router 1 is going to send the traffic to the 4.0 network, it will send the traffic by the router 2. If the router 1 is going to send the traffic to the 44.0 network, it will send the router 2. If router 1 is going to send the traffic to this guy, he will send the router 2. It means that we are not going to utilize this particular link. Okay, this is the backup link. Backup always comes in the picture when the primary goes down. 100% right. But dude, you are a network engineer, right? The company will pay you lots of money. So why they are going to pay the lots of money to you? Because you are the smarter, right? So do the smart work. What you can do that now? Okay, my router 2 is the primary link because it's the best path because of the lower metric, right? But what I want, okay, let's do one thing like this, right? What I'm saying that only for the 4.0.0 network, right? So whenever the user will send the traffic for the 4.0 network, my traffic will go by the router 3. Remaining all this thing, remaining all the flow, right? Remaining 44.0 and 172.16.0, it will come by the router number 2. So only for the certain doubt, I'm going to change the path. That's called the selective path manipulation. Okay, little tricky, but very, very important. Little tricky, yeah, it's very important. That's called the selective path manipulation. So for the certain doubts, I can change. So in this case, what happened? I will utilize this particular link as well and this link as well. And you know what happened? If this link goes down the west path, I still have a backup path for this 2 network as well. That's a beauty part you have with the selective path manipulation. How you can achieve simple formula whenever the selective comes in the picture. Remember the VLAN access list vehicle concept in the VLAN. Same concept over there. We'll do that. What I can do, let me remove the offset list from right now. Router EIGRP. No. I remove everything. So everything is normal right now. So do show IP route EIGRP. I'm doing the equal cost load balancing. Wait a minute. Take some time to refresh it. Yeah. I'm doing the equal cost right now. Okay. Now what I want it was messy again. What I want, so I'll put the thing over there. I want router 1 wants for the 4.0.0.0, it go by the router 3, right? And for the 44.0.0, and this go by the router 2. This is the things that I want to achieve it. So if we are doing these manipulation on router 1, then it should be in mod. If we are doing the same thing on the router 4, it would be the odd one. It's depend on the flow. Got it? So simple language, what I can do that? Selective path manipulation. Matrix calculation. I'll put the formula over there. I forget to put it. 10 to power 7. Come on, 10 to power 7. Least bandwidth. Lower bandwidth. Simple language. Plus total delay divided by 10 into 2.6. This is called as a PCM. That's done. Obviously, we are doing that. Hold on. Selective path manipulation. Good, right? How we can do that? Of course, we are selecting it, right? So select it, access list. What? Okay. One. I'll call this guy format. Wildcard mask. I'm just going to match this guy. And remaining, I'm going to match unmatch over there. And so the router EIGRP number 1, offset list, the ACL number 1, in mod, add the offset value. I'm going to add the 500 on which interface? On 0/0. So on this particular interface, I'm adding the extra values over there. Extra values, extra metric I'm adding. For which network? So take example, if the route is coming from this way, then what happened? If the route has a matrix of 1000, I'm adding the 500 plus. So it will be the 1500 from this side. And from this side, what happens? It's coming like 1000. So which one am I going to pick? 1000, of course, right? Lower matrix. That's done. So if you see, if I'm going to put this command, then what happened? We are going to achieve it. Bingo. Hold on, take some time. Can you see that? 13.3 is the best now. That's we got it. For remaining 2.1, what he's doing that? Default behavior man, ECNB. So if you want certain kind of condition, you can also do that. But I want this should be go by the 12 or 2. So for this guy, what you can do that? Access list to commit. Which one? All done. EIGRP 1 offset list. What I want, man. And I'll make this guy the 2 matrix. Sorry, ACL number 2. Right? And I call this guy the inbound. How much offset I'm going to add? I'll say the 2000. Any value you can take it. It's a huge number, man. And on which interface? 0/1. So take example, if this 2 route, right, is coming via this way. So the actual matrix is 1000. And also from this way, actual matrix is 1000. So what I'm doing now on this particular interface, 0/1, I'm adding the 2K extra. So it will become 3K. So of course, for these two guys, what happened? Previously, I'm doing the load balancing, equal post load balancing. I'm not going to do that. I'm going to make this guy the best. Data number 2, so be the best. Perfect, right? 13.3, 4.0.0 network, and remaining for 44.0, I have a 12.2. So now I'm using my network smarter. So I'm able to utilize both the link man. So if the user is sitting behind this guy, and if they will send the traffic to the 4.0.0 network, the traffic will go by this way. Right? If they will send the traffic to the 44.0 network, they will go by this way. Even for the 172.16.0 network, they will go by this way. That's the smarter things we did. And of course, it doesn't mean that this is the primary link for the 44.0 network and 172.0. So if I'm going to shut down this link, 0/1, I have a backup man still. That doesn't, that's also a good thing. I'll still have a backup. See that? 13.3 now. Also 13.3. But when the primary comes up, it will go by the primary only. All good, right? Anyone has a questions? In path manipulation, is it clear to everyone?
Yes, sir.
Yeah, I have a question.
Yeah, Feroz.
Is it possible to only one way for incoming, one way for one router for outgoing? Like
What do what do you mean by
from
incoming?
this means from router 1 to router 4.
Oh, so you're
Uh,
saying that so for the 4.0 network, you're gonna do on the router number 1 as an inbound, And for the
not for all the networks. One way through R2 it is going towards R4. Through R1 it is towards R1. I mean, sorry, R3 towards R1.
Firoz, right.
You didn't get it right?
Yeah, of course, yeah, I didn't get it.
Okay. Let me explain it again.
Yeah.
From R1 to R4
Mhm.
via R2, it
Okay.
is this way. All the networks.
All the inputs, okay.
From R4 to R1 via R3. This way.
For which network?
R4 to R1. All the network. Is it possible or not?
So the whatever the network behind the router one?
Yeah.
It's possible. Same thing. So whatever the things you did on the inbound on the router one, same configuration you can do on the router for the inbound for this network.
Okay.
You can do that.
I'm a little confused about, and more than confused, I'm a little curious about his question. So is he?
His question is that, so right now we have a route. Okay, what I understood from the videos right now. So take example, whatever the routes we have a router for. So same route we have a behind the router one. Right, Firoz?
No, only this actually.
Yeah, that's why
no
I
need
thought
to
he's
add.
just talking about one-way traffic from R1 to R4 via R2.
You're talking about
and
the ICMP request packet. You're talking about like this way.
No, all the traffics. I mean, not only ICMP,
I mean,
regular
so all the
traffic.
traffic you're saying that all the so
Yes.
so that's why I'm asking the question to you. So try to understand. So if there is a user behind this guy, right? One, right?
Correct.
Submit over there, right? So
Correct.
you want whenever the traffic will go via, whenever he will say the ping, right? 404, the traffic will go by the router number 2. You want like this, right?
Correct.
Yeah. So
The response would be through R3.
You can do that now. You can do that.
Yeah,
You can change the offset list. You can do that. So now, but
okay.
in that case, what happened? You can change the you can change the metric calculation for this particular output. You can do that. That's called as a asymmetric routing. Asymmetric routing means what? The reply request will go by this way and reply will come by this way. That's called as asymmetric routing. If the request will go by this way and reply also coming by this way, that's called as a symmetric routing. But if the request will go by this way and coming by this another way, that's called as asymmetric routing.
If the R2 is down, the both I mean incoming and outgoing will be through the R3, right?
R3 only, right?
Yeah, okay. I got it. Thank you.
Okay. Pradeep, you understood, right?
Yeah.
Yes.
Okay.
Thank you both.
Okay. Now, what I want to do that now, something is called as a EIGRP is the only routing protocol, just for your knowledge right now. In future, if you go in the high level, then you will get to know that more. But yeah, I can say that CCNP and CCI level, right? EIGRP is the only routing protocol that supports unequal cross load balancing, man. Okay, I'll tell you. Before the EIGRP, you guys know that EIGRP protocol was there. EIGRP also supports the unequal cross load balancing, but nowadays we are not using it. That's why the people are saying that EIGRP is the only routing protocol that supports the unequal cross load balancing. Unequal cost means what? Take example. I'll remove everything right now. Okay. Okay, you should also remove it. Quite right. So I don't have anything right now. Okay. So everything is equal cost right now. Do swipe into the EIGRP. Equal cost. Right? So I will be doing the load balancing from here. So two types of load balancing we have: equal cost load balancing or unequal cost load balancing. In the equal cost load balancing, right, the metric will be same. But what happens if you see that 0/1 0? I'm gonna say that delay will be what? Take example as the 10 now. Default is 100. I just set the 10. So now what happened? All my traffic will go by the router 2 only, because router 2 become the best, because delay is by default 100 on this guy, 100 on this guy. I change, make this guy the 10 over there. 10 second, it means that 100 microsecond. 100 second means that 1000 microsecond. So this is why we do EIGRP. 12.2 is my best one. So this will be my successor route. This will be my feasible successor route. Now tell me one thing. Can I utilize this particular link? No, because my traffic will go by the 4.0, 12.2. My all traffic will go by the 12.2 only, right? I cannot utilize this particular link. There will be no load balancing now, because the cost is not same. Because the cost is not same. EIGRP allow you to get unequal cost load balancing. Unequal means what? When the cost is not same. When the cost is not same, then you can achieve unequal cost load balancing. Only one condition is there to get the unequal cost load balancing. Only one condition. The condition is what? Condition is there. बहुत टाइप करना पड़ेगा, कॉपी करो. Only one condition. You must have feasible successor in topology. If you don't have, you cannot achieve it. Check it. Do we have a feasible successor right now? So IP root EIGRP. So IP EIGRP topology table. I do have. This is the one successor. That's my successor app. And this is my feasible successor. I do have one. This is my successor app. And this is my feasible successor app. If you have a feasible successor, then you can achieve the unequal cost load balancing. How are you going to achieve it? How you going to achieve it? What you can do that? See, this is the lower one. Can you see the 41? 41 is the lower one. 43 is the higher one, right? This is the lower one, and this is the higher one. You have to make, right, this lower value equal to this one. Either you can make it equal, guys, please pay attention. Either you have to make this guy as equal to this guy, or you have to make a higher. You have to make, let me copy this word and I'll paste it in the notepad. Let me make it in the paint file as well. Right? So this is my successor one. Guys, ignore this spelling. Successor and feasible successor, right? So if you see that, that's my successor path. Right? And the bottom one, my feasible successor. You can see that this 41.0, right? 41 is the lower and 43 is the higher. What you have to do that, this path will be there in the routing table. If you see in the routing table, successor one, not the feasible successor. Feasible successor only comes in the picture when your successor goes down. And to achieve the unequal cost load balancing, you must have a feasible successor in your topology table. That's one of the best requirement. Now, how I can achieve the load balancing? See, you have to bring this guy into the routing table. You have to bring this guy in the routing table. So I cannot lower this value. Simple logic. I cannot lower this guy, but I can make this guy as a higher. How? What you have to do that? You need to make this guy. Let me write on this thing. So you have to, this is the, I'll make this guy star. You have to make successor FD. Why I'm saying the FD? This value is called as the FD value, right? This is called as FD value. This is called as AD value, or we can call as RD. Again, this is called as FD value. This is called as RD and AD. So you have to make successor FD equal or higher to the feasible successor FD. So equal or higher to the feasible successor FD. So how you can make a higher? So simply what I can do that, I'll just gonna 412160. I cannot make a equal, obviously, right? So I'll just gonna multiply by 2. This multiplication value, this value is called as a variance in the EIGRP. Again, this is a logical. So when I'm going to multiply this thing, what happened? It will become the something around 8 lakhs something, right? Something in the year around 8 lakhs. So it will become the higher from this value. This 8 lakhs something you will have, it's a logical one. You cannot see in the routing table, not even the topology table. Okay. You cannot see in the routing table, but not in the topology table. EIGRP does this thing in the background by changing the variance. So when the variance will be 1, remember one thing. When variance is 1, it means that there is no unequal cost load balancing. You can change up to 128 on iOS. How I have to make it? So if you see right now, so IP protocol, it's 1 right now. So the variance is just gonna multiply. It's a multiplier. Variance is a multiplier of your successor FD. It's a multiplier so that I can make it equal or higher than the feasible successor FD. So I'll just need to go. How much value I can do that? I can, if I'm going to make a 2 over there, I can easily get the higher than this one, right? Simply. So I'll say that outer EIGRP, you can see that as the variance. And what is it? It's a multiplier. So I'll put the anything, I'll put the 2 over there. So if I'm on 2, so it will become the higher than this one. So IP root EIGRP, now you can see that. I got that. So as I mentioned that this is the logical value, you will not see in the routing table, not in the topology table. But EIGRP does this thing in the background. So you can achieve the unequal post load balancing as well. All good? Anyone has a question, guys?
Not at the moment.
So IP protocol, you can check the variances too now. So let me change the sky, the command. Show IP protocol will give you the verification for the variance. Let me share the sky. So that's done. If you want more, I can give you, but I think so it's enough information today. So let's digest you guys first, then we'll see you tomorrow with something more interesting with the EIGRP stuff. Or maybe yeah, I think so. Yes, EIGRP stuff, we can do that. Yeah, we'll do the EIGRP stuff and we'll try to do the ACL concept as well. So I'll teach you how to create the ACLs and everything. What is the use of ACL, right?
Yeah,
See?
we should yeah first complete the EIGRP, whatever you were saying. I second that idea.
Yeah, stop. We'll do the ACL as well tomorrow. We'll first cover the stuff, then we'll do the stuff, ACL as well.
Okay.
Okay, guys, I'll catch you tomorrow. See you. Bye-bye.
You say good
Thank you
night.
very much.
Hey, bye-bye.